Hi. I'm Jim Heffron. I want to talk about LaTeX packages for beginners. If you're a beginner and you started working with LaTeX, then probably you have come to some point where you want to, I'm confused, I don't know how to do something, and maybe you asked for some help and people told you there's a package for that. So the next question that a person would ask, of course, is, well, how would I know what there's a package for? Where do I find them? If there's two or three packages for something, which is the right one? These are all perfectly reasonable questions. So I've put together a document, first set of LaTeX packages, that give a person some first look at what packages are available based on experience with working with beginners. What kinds of things do beginners look to do, and what packages are there out there that would help a beginner do those things? Okay, and let's go through them quickly. Just to roughly run through it, and so a person would at the end have some idea what was available. Okay, so the idea of the list is that it covers what a beginner wants to do based on experience with beginners. It tries to cite one package in each area, package that of course is capable and reliable. You don't want packages that don't work, and that come in the distributions. So however you got TeX or LaTeX on your computer, or whether you use an online system, the packages listed here come with all of those systems. Every once in a while, I'll make a comment in the document. It's in parentheses that often comes up in conjunction with the recommendation. I mean, every time somebody asks about such and such a thing, then you always need to say, here's this point. I threw that in this document. Okay, before I get into the list, I want to talk about a couple of small points, but they're key points. The first is that in many software systems, in order to find something, you have to go hunting all around the world. You go to GitHub or GitLab, or you go to SourceForge, or you Google it and find people's web pages, and that's not true in TeX and LaTeX. In our world, there is a central repository called the Comprehensive TeX Archive Network, CTAN, C-T-A-N, that holds the material. If you ever develop material yourself, you should upload it to CTAN and make it available to others. It's a website. I'll bring that window up if I can make it work. There we go. Here's the website. You can you get some idea of what we're looking at here. It's the front page, so there are some announcements, some idea of activities, something about what is CTAN kind of stuff. You can get it on DVDs, and then some idea of what TeX is and how to download a TeX system. So this is the front page. I'll show you in just a minute what it looks like when you get a package from CTAN. But for the moment, I want to get to the packages first. So let me do that. Before I get to the packages, I just make a comment or two, and that is that documentation. The documentation for packages is on CTAN. You can go there and look, but maybe more conveniently, the documentation for all these packages is probably on your computer. I mean, you could have, refused to download it or deleted it or something, or probably you have it. And the way to get it is opening a terminal window, opening a command line, and just typing TEXDOC package name, and that'll at least get you started. Okay, and then finally, one more note before we start. If you're writing for a journal, if you're writing, say, a master's thesis for a university, there's a reasonable chance that those institutions, the journals or the universities, already have a package that you're supposed to use when you write for them. So you should either ask them or else Google around or go to CTAN. CTAN has a whole bunch of these. The idea is, though, that you shouldn't be trying to reinvent the wheel. If somebody has it already available, then you should use what's available. Okay. All right, so enough preliminary stuff. Time to talk about some real stuff. So I've broken the document up into a couple of parts. The first part, it talks about what applies to every document that a person writes, or at least that I write. The kinds of considerations that a person thinks about every time they start a new document. Okay, so just to try to help a person organize the different parts. Okay, so for every document, you usually have to worry about things like page sizes, margins, is it landscape, or this kind of stuff. The right package there is called geometry. I'm going to use geometry as an illustration of what's on CTAN, but let's see if I can bring the darn thing up. There we go. As an illustration of what's on CTAN, this is what a package page on CTAN looks like. Can you see the URL up here? It says ctan.org, and then PKG, and then geometry. So this is the geometry package on CTAN. You see that it gives a brief description, flexible interface to document dimensions, some very brief description of how it works, all kinds of links here. You can get the source code, you can read the package documentation, you can go to the GitHub repository, you can see what the license is, the author's names, which distributions it's in, and some other things down here too when it's been active. In particular, before I leave this page though, I want to point you to something that is not widely enough known, and that is that it's listed as being in the topic geometry. If you go to that topic, what you'll see is that CTAN has classed together a whole bunch of different packages. Some of them may be a little less useful, but some of them very useful, that all speak to kind of the geometry of the page. So if you need, for example, an A4 page, then this would be a place where you could look. These tags are very handy and not widely enough used. Okay. Okay, so back to my list here. Am I doing the wrong thing? I am doing the wrong thing. There we go. Okay, so to change the page size or the margins or the orientation, you want to use the geometry package. And if you're going to get multiple columns, I know that LaTeX gives you 2 columns, although it has some disadvantages. It breaks to a new page, for example. But if you need more than 2 columns, then multi-col is the name of the package. Many people who work with Tech and LaTeX want to make mathematical documents. Not everybody, but many people who work with Tech and LaTeX want to make mathematical package. If you have a document that contains a significant amount of mathematics, you want to use the American Math Society's AMS package, and the AMS SYMB, I'm not 100% sure how to pronounce it, AMS SYMB, I don't know, packages contains obviously a variety of symbols. Sometimes you also want to write theorems, and so you need some way to say, how do I declare a theorem, how do I declare a lemma? I use the AMS theorem package for that, personally. There are others, but I'm just going to list the ones that I use because I think I try to use ones that are sort of careful and reliable and widely used. Couple of notes here, just as a comment. AMS SYMB inputs the AMS fonts, so you don't need to input that yourself. Another comment, many authors use the calligraphic characters in the Ralph Smith's formal script, RFSF, so you might see, a big P, scripty P kind of stuff. The right way to get bold math is with the package BM. You want to load, you want to load AMS theorem after AMS math. Some advice that I think has helped me a lot, and that many people would not know who are beginners. Don't load AMS Math directly. Instead, load the package Math Tools, which will load AMS Math, but will also load a lot of improvements. And the example that I'll give is I write a lot of equations. I'll have left-hand side equals right-hand side, and then boom, 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 and then I want to put dot, 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 and then left-hand side equals right-hand side, and I want the dot, dot, dots to be centered between the equal sign. So there's just centered left and right on the equal sign. Math Tools has one of the things that Math Tools has is a way to do that. So some useful improvements over AMS Math. AMS Math is great, goes 95% of the way. Math Tools takes you sort of another, sort of 4% of the way. And then finally, the microtype package, which very finely adjusts the spacing and the size of letters, that kind of stuff. My eye is not very sophisticated on it. I can't see the difference, but I appreciate that it means that there are fewer lines that stick out in the margin or this kind of nonsense. Okay, so those are the things that apply to every document. If once I get inside a document and I start working with the actual text, one of the questions that we hear a lot is tweaking lists. How can I make the things on the list be not boldface but instead italics kind of stuff? And the right package there is enum item. A lot of people write about floats. There seems to be not really a wide understanding of floats. It's not something that a person runs across, I guess, in writing sort of Microsoft Word for philosophy class. But so for floats, to do better with captions, you want the caption package, the well-named caption package, and you can control floating environments with the float package. In particular, people often ask the question, I want this thing not to float to 3 pages later. I want it right here. And that's a very dangerous thing to do. I mean, if you have a too tall figure, a two-inch tall figure, and it's got to fit in 1 inch of space, so there's a reason for floats, but sometimes people say, no, I understand all that, but I need it to be here, and this package has an option that puts things just exactly right here. Okay. For hyperlinks, I mean, this is, this is, we're in the 21st century here. For hyperlinks, you want to use the package hyperref. It's usually the last thing that you load. Every once in a while it's the next to last thing that you load, and one reason it may be the next to last thing that you load is because you might want to use the package cleverref. Cleverref is a good example in my mind of a person who has in mind that the computer ought to be doing that. Why am I saying theorem 1.2? The computer knows that 1.2 is a theorem. Why doesn't the computer print that out? So cleverref arranges for that to happen. And then the other package that's kind of related to this pile is URLs. If you have to make a URL and it's full of funny characters and you're worried about breaking it across lines, or file paths are the same thing. If you have a long file path with 5 separate components and it's 30 characters long, but you need to break it because otherwise it sticks out into the margin. Okay, so the URL package will do that. Another thing that people often ask about, and then I have a lot of trouble with myself, I work a lot with myself, is how to make code listings. So this is a little bit of an exception to my mention only one package rule that I talked about earlier. So the most common way to make code listings is to use the package called listings. But I'll mention that Minted, M-I-N-T-E-D, Minted is also a great way to do it, and the two of them in some ways complement each other. But anyway, Minted has a lot of advantages also. I'm going to focus on listings because that seems to be what the great majority of people do. One thing that is a cheap fix is to make single quotes inside verbatim come out correctly. You use the package upquote. Instead of getting like a quote that goes this way and a quote that goes that way, kind of stuff, and it looks really, you just want a couple of straight up upquote. Upquote is the way to do it. I have another one of these tangential comments. So copy and paste for computer code listings. This is an issue. It's an issue, my understanding is it's an issue with PDF. That PDF doesn't just put spaces where you ask for spaces. It does all kinds of fancy stuff, and 99.9% of the time that's great. But this is one example where it's problematic. And in particular, if you want to copy and paste for computer code listings and you want that some of your code is indented, which is what I always want, some of my code is indented, then you're going to run into some trouble. The parts that aren't indented usually work out pretty well if you do what it says here, but the parts that are indented, if your code line begins with blank spaces and you do a copy and paste, then those spaces are gone, and there doesn't seem to be a fix for that. Doesn't seem to have to do, my understanding, it doesn't have to do with LaTeX, it has to do with PDF. One reason that I have a lot of indentation is that I'm a Python user, and for Python users, the package Python Tech will show the code listings, but it also has the advantage that you can run Python code and put the results in your output. It's really a great package. So if you want to execute some difficult operation and then just simply put the results in your document, then Python Tech will do that. Another package that will do that, and this time it does it for Sage, for the Sage mathematics system, which is a Python related, is Sage Tech. Again, shows the code listings pretty, but also drops the result of a computation right in the document. And similar systems exist for other languages. Tables. Tables seem to be one of those things that people have a lot of personal opinions about. So I'm not gonna stick my opinions on you. But I'll say that there are many, many packages. If you say to yourself, you know what I need to do? I need to have that the third line and the fourth line, or I need some entries on the third line and the fourth line to span the two lines. I need multi-row entries. Okay, well, there's a package for that. And somebody else might say, well, I have a very long table. It's got to span more than one page. Okay, well, there's packages for that. So usually if you say to yourself, I need, there's a package for that. I didn't want to list 15 different packages and have a person be confused over exactly what are the capabilities of each, except I'll say to you, Google that. I personally consider the most basic package to be the array package, which lets you define your own column types. So, I want a column, for example, that is all in italics. Everything in that column will come out in italics, kind of stuff. And I'll mention, while I'm here, it's related to tables. I'm not sure how to pronounce this either. SI unit X. I'm not sure. So it does units, physical units. If you want to say, for example, 5 kilometers per hour kind of stuff. It'll put in the right spacing and all that business. Put kilometers in the right font, all that kind of stuff. But it also has a table column type for aligning on a decimal point, which is often asked for. And then finally, to finish this section, if you want to make boxes that are colored or framed, such as when I write, I often want to make theorems have a shaded background. If you want to make boxes that are colored or framed, then you should use the package tcolorbox. Okay? And again, documentation for all these packages is on CTAN. Graphics and color. So there are two packages for bringing in graphics. One of them, the name ends with an S, and the other one, the name ends with an X. Perhaps a little bit against your intuition, you want the one that is misspelled. You want the one whose name ends with an X. Though really, the other one is really for backwards compatibility. LaTeX Tech and LaTeX want you to use JPEG for photos, PNG for other kinds of dot by dot, raster graphics. And for vector graphics, they want you to use PDF. Okay, so photos or drawings would be something like JPEG or PNG. And PDF is for vector graphics, where you instead of putting a line, for example, dot by dot, it draws a line, and it relies on the system to make it bigger or smaller. If your graphic is in another format, then you just want to convert it to one of those three. That's all. And finally, the tip on graphics here is that we often get people ask about. Usually you want to include the file name without an extension. So rather than graph.jpg, you probably want to say just graph. And the system will figure out that the only file named graph in that directory is graph.jpg. This is a somewhat technical point, but suppose you had graph.pdf and graph.jpg. Graph.pdf is better because it's a vector format, so if you don't put an extension, then it'll choose the better of the two. Anyway, so usually you leave the extension off. Finally, you can include parts of another PDF document with PDF pages. You want to say, I want to bring in pages 5 to 7 of this other document. So it comes in handy surprisingly often. You think to yourself when you first run across that, oh, how would a person do that? Well, it's very easy with this package, but that seems exotic. And then you find yourself doing it over and over again. It's kind of surprising. And then finally, video or sound. The package that you want to reach for is called Media 9. I know there's a Media 1.5 and there's a Media 9, and you think 15 is bigger than 9, but you want 9. 15 actually means 1.5, which is smaller than 9. Anyway, you want Media 9. For colors, there's a standard color package, and there's also Xcolor, and really Xcolor is the one to reach for. Although I personally find the documentation hard to make out because, have you caught on yet? I'm not that bright, and I can't read the kind of abstract documentation. But usually I can figure out what I want in a couple minutes, especially a couple minutes spent Googling. But it's a very capable package. Wonderfully capable package. To make plots and graphics, everybody does something different. It seems like when you talk to people, I say, well, I use GNU plot. Well, I use R. And I'm not saying any of those things are wrong. I can only list one or two things and say, if you have no idea, then here's something to do. So to make plots and graphics, I personally use a package called Asymptote, which is a full-fledged program, and it's if you know anything about Metafont and Metapost, it is a development of the ideas of those two that GNU Knuth developed that includes three-dimensional constructs. It produces the sort of most natural way to work with it. It produces standalone graphic files, PDF graphic files is how I do it, and then you bring those PDF files into the document with the commands that I talked about a minute ago. So I find that the most satisfactory myself personally. I don't like having a very long compile chain. However, honesty compels me to say that I think the majority of people don't use a separate program. Instead, the majority of people compile their graphics write and compile their graphics inside of LaTeX using a system called TXE, PGF or TXE. I do think the great majority of people use that. There's nothing wrong with that system. It's a great system. But I happen to use this other system. And so, again, I made an exception to the one package per area rule to mention these two. Okay, front matter, back matter, headers and footers, the kind of decoration that goes around the core of your pages. A chapter and section titles. You say, well, I want it to be like a hanging indent, so long line and then an indent and then a shorter second line. Title sec. Page headers and footers. Fancy header. You can tweak the format of tables of contents and lists of figures with TOC LOFT. Basically, what that does is parameterize all the distances. So the distance between the title of the chapter and the page number will be a variable, and you can set that variable and make the distance shorter. You can't do radical things to the table of contents, but you can, if you say, well, I need a little more space there, this is exactly the package for you. Answers to exercises. A lot of times a person is making up, say, quizzes or exams or textbooks and wants to have answers to the exercises. So what you want to do is you want to put the answer right after the exercise. And so you want to have LaTeX read the exercise and then take the answer and put it out to an external file. Maybe read it in at the end of your document where all the answers are. Or maybe read it in as a separate document, answers to the book kind of stuff, which is the way I personally do it. So the answers, the answers package is the thing to do there. It will take the material that you typed in and ship it out as is. No expansion of any macros. It just ship it out as is to an external document. Footnotes. Everybody likes different things, but FootMISC is a package that tries to tie together a whole bunch of different packages. So it's kind of the one to use in the sense that you don't have to go around and find 5 different packages. One package to put them all on one page, one package to number them alphabetically. No. It tries to be kind of a joiner together of all those things. And to make an index, I used the sort of venerable make index. There are ways to make multiple indexes, but anyway, I use make index. Bibliographies often give a person a lot of trouble. You might have strict requirements. Maybe you're writing, for example, for the Modern Language Association, or maybe you're writing a document that has to be according to the rules of some professional society. So what you probably want to do there, you probably don't want to write it yourself. You probably want to find that somebody else has written it and you can just grab it. So in our age, maybe a person's first impulse is to use a search engine, is to just Google the darn thing. But I'll tell you, the first thing you should do is instead go to CTAN. CTAN has a collection of packages that people have already written, either to use with BibTeX or to use with BibLaTeX. I personally use BibLaTeX, but it seems to me the majority of people use BibTeX. And if you look there and you see, oh, there's a package for MLA, and there is a package for MLA. There's a package for MLA. I'll just grab that. There's also a program that you can run that asks you questions. Do you want the first name capitalized? But really, the simplest thing to do is to find that somebody else has done the work. Okay. So special documents, by that I mean documents that aren't kind of books or papers. So for exams and problem sets, the exam class is the thing to do. Now, this is not really a package, it's an entire document class, but I'm throwing it in this list because it's something that people ask about sometimes. You can ask questions and then type the associated answer right after it, and then there's an option at the beginning of the document where you say show the answer, don't show the answers. CVs or resumes. People very often, as their first LaTeX document, I'm not sure I understand this phenomenon, but people very often, as their first LaTeX document, will write a CV. So, of course, you can find it Google around, or maybe you find it on some site where you do LaTeX on the web, Overleaf, for example. But another place where there are lots and lots of choices is you go to the topic, the CV topic on CTAN. I showed you earlier the topic for geometry, the CV topic on CTAN, and you have a look, and there's a bunch there, and it's possible that none of them suit you, but I bet you one of them is at least awfully close. And finally, presentations. What most people do for presentations is they use the Beamer class. And I use the Beamer class. That's really the way to go. I have to say though that I'm recommending it with a little bit of reservation in that I have a document here full of packages that can help you accomplish what you want to accomplish, and most of them are completely useless in Beamer. Beamer has its own way to do all these things, and I often feel like I want sections to be in a little bit larger type, and I have to learn a whole new way to do it. Anyway, that's Beamer is the thing that people most often do. It certainly is great for exposing first one thing, then another kind of stuff. So if you have 3 points on the slide, you can click, show the first, click, show the second, click, show the third kind of stuff. Okay, really the last points. So fonts. So a person who writes some LaTeX at some point starts saying they all look the same. And one thing you can do besides change the document class, like these classes up here, is to change the font a little bit. So what are your options? And there's somebody has gone through the trouble of collecting together the LaTeX font catalog. Shows many choices. I'm sorry, I don't know how many. Must be hundreds. I don't know, 150 choices, and it shows you the document along with a working math pair, and it gives you the copy and paste code. If you want this, copy this into your document, and it'll just work. So that's wonderful. That's what I need. I don't need to figure it out. I'll tell you that. Beyond that list, which is a great list, a lot of times people will ask a question. They'll say, "Well, I'm not really working with math so much. I'm working with just text, and in fact, it so happens that I have to work with the following font. I'm required to work with the font, this font here that I have on my document, that I have on my computer, and I don't know how to use this font that isn't sort of already cooked up for LaTeX." And that the answer for that is that there are 3 ways to use 3 programs that you can use called engines that convert your input LaTeX source to output typically PDF. Okay, the 3 are called PDF LaTeX. It's the sort of earliest and the one that most people use. Almost everybody uses. Not that it's wrong to use other things, but it just seems like that's where people are right now. There's something called Z-LaTeX and something called Lua LaTeX. And the Z-LaTeX and Lua LaTeX engines can use any document on your system, any font on your system, any font that your system knows about. If, for example, you have a little program on your computer that looks through all your fonts, any font that your computer knows about, these 2 systems can find it and use it, leveraging the font spec package. Okay, just a word of caution here. Often people write papers for the archive.org, and for archive.org it doesn't really like the source code of these, because how do they know what font you're using? So you can only submit a PDF, not the document source. But so you can get any within reason, you can get any font that you have on your system. If for some reason you want to use one or another, you can absolutely switch over to Z-LaTeX or Lua LaTeX. Usually, in whatever program you use to write LaTeX, it's just a menu option. You go up and it'll say something like compile with, and you click on compile with, and there'll be 3 choices: PDF, Z, or Lua, and just pick one. I don't know, personally, I would probably pick Lua at this point in history. Okay. And then finally, LaTeX, just a comment for internationalization. LaTeX defaults at this point for a couple of years now to UTF encoding input on all 3 engines. And if you want to do internationalization, the package to use there is Babel. excuse me, Babel. So, for example, what I mean by internationalization, instead of printing out, say, a bibliography, you wanted to print out the word for bibliography in French, or whatever that word is, and the Babel package will fix that so that it does what you need to do. Okay, finally, just to wrap up here, so I'm very interested in keeping this document up to date, periodically revising it from time to time. So if I've got something wrong, or if you have some better suggestion, or you want to write me and say this package has really stopped being developed now, and there's a new package that does a better job, then please, I'd be very interested to hear, and my contact information is on that page. Okay, very good. Thank you. Bye bye.